Page 465, number 41. An airplane is flying on a bearing of 335 degrees at 530 miles per hour. Find the component form of the velocity of the airplane. So you want to remember how bearing is defined. So what we want to do is realize that it's based on due north. So the plane is starting at 335 degrees from due north is the way it's flying. So if I were to draw that, what I would have is I'd have a picture like this. So due north around to about there. So here is my resultant vector like this. So we have to take into account some angles here. So one of the angles we're going to take into account is this angle right here. That angle, since this is 335, the angle that I drew in yellow here has to be 25 degrees. So please remember that the angle that we want is from the x-axis to where the vector is. So the value we really want is a value of the 90 degrees to north from the x-axis to here, and then we're going to add to that the 25 degrees. So our theta is actually 115 degrees. Once you do that, doing the rest of this problem is pretty straightforward. So we're going to use the idea that V is going to be the magnitude, which we're given is 530, times the cosine of our direction angle, which is 115 degrees, and the y component is going to be our magnitude times the sine of our direction angle, 115 degrees. So now putting that into our calculator, we get the values as negative 223.99 for the horizontal direction and 480.34 for the vertical component.